Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first three problems of Codeforces Round 866, which was written for Division 2. So I believe that this round was pretty balanced and the overall difficulty of the problems were okay. The third problem was not very difficult. I would say it was easy medium, and the fourth problem was like the difference between the third problem and the fourth problem was a bit big, as you can see by the number of submissions. So as always, this contest was not very good for me. I made a couple of wrong submissions on almost every question. So but still, we're going to discuss the correct solutions to all of the three problems for division 2. So let us discuss the first problem, which is Yura's new name. So in this particular problem, we want to make sure that we have been given a string s, and we want to make sure that the string only contains either these characters or these characters, right? And every character present in the string should be a part of either this particular three characters or these two characters. For example, these two characters is a part of this particular style, right? Of this particular pattern. But if you see that if you take these three characters, now these three characters will not be a part of either the first pattern or the second pattern, right? So we need to make sure that all the characters are either a part of this particular thing or this particular thing. This is our question, and we want to make this happen in the minimum number of steps, and we have to tell what is the minimum number of characters that we need to add to make the name possible, right? And the condition is only this, that each character should be either involved in this pattern or involved in this pattern. So let me just discuss some sample test cases with you, and you will be able to understand the problem better. So this is the first problems test cases that we have here. So the first character is this 1, 2, 3, 4, 5, 6 underscores, and then again this character. So obviously, there are some places where we have to insert some characters. For example, the first place I will have to insert is this one, the second place is this one, third place is this one, fourth place is this one, and the fifth place is this one, right? If these characters are not there, then the two underscores together, right, will not be in a pattern, and will not belong to either of those patterns. So you must have observed one thing till now. The only two patterns that are possible, right, are this one and this one, right? So if two exponentiation signs are together, then there is no problem because it belongs to this particular pattern. But if two consecutive underscores are together, then it is a problem because it does not belong to either of those patterns. So what we can do is, if for example, if an exponentiation sign was here and the other was here, now two underscores are together, what we can do is we can insert one more sign in between them, right? So this is the first thing. This is the first thing that we have to do. Whenever two underscore signs are together, we can insert an exponentiation sign between them, right? So that it becomes a pattern. We are currently assuming that one must be to the left of it and one must be to the right of it, right? So we are only considered about the between these two places, right? So if we insert this particular character between two underscores, then we will form our correct answer, right? So this is the very first condition. Now, since we have assumed that there is always one character at the beginning, this particular character at the beginning, and the other exponentiation character at the end, we need to make sure that this happens when the underscores are at the two ends, right? So this is the second condition that we have to check. So if there is an underscore at the beginning of the string, we need to add one character to the left of it, and if there is an underscore at the end of the string, then we need to add one character to the right of it. Right. So this is the second condition that we need to make sure. And there is also a base case that we will discuss. For example, when the size of the string is, when size of s is equals to 1. So either it can be this particular character or it can be an underscore. So if this is the exponentiation character, we can add one more exponentiation character, and the number of additions will be 1. So the answer is 1. If we have an underscore, we can add one before it, one after it. So the number of additions will be, and the answer will be 2. Right. So if we consider this base case separately, we'll have two conditions remaining, right? So let me just quickly summarize through what I just told about you this particular problem. So let us first discuss the base case. The base case is that whenever we have one exponentiation sign, we can insert another one and we can form our answer. So in this case, the total number of steps will be 1, or we have to add one more character. But if the only character is an underscore sign, we need to add two exponentiation signs, one to the left of it, one to the right of it, and the total number of characters that we have added will be 2. Right. So this is our answer. Now, what happens when the size of S is greater than 1? So as now, since for now we'll assume that there is always, if there is an underscore to the leftmost thing, to the leftmost part of the character string, then we assume that there is a character exponentiation character to the left of it, and if there is an underscore character to the rightmost of the string, we assume that there is an exponentiation character to the right of it. Right. So we will be adding these characters, and that is what we discussed case number 2. Now, since if there was an underscore, there is an exponentiation character, we don't need to worry about it. We just need to worry about the places that are between, right? So for the places that are between these two places, what we have to do is we just have to make sure that whenever there are two underscores together, we need to add one more exponentiation sign between them, right? So this is what we are going to do. So we just have to count the number of underscores or two consecutive underscores. Right, we just have to count their number, and that would be that, and we'll add that to the final answer. So let us have a look at the code. So the way I implemented it, what was quite messy, like all of the three problems, but I'm going to explain you the code, and you can simplify it and write it in your own way. So what I'm doing is I'm creating a string S, and I'm taking input in it. So the next thing I do is I just check whether the size of the string is 1. If it is 1, I just check whether the only character that is present in it is equals to the exponentiation character. The answer would be 1, otherwise the answer would be 2. Right. So this is the first part. Now I just return from here so that I don't execute the rest of the statements. Now I initialize my answer with 0. I check whether the 0th character is an underscore. I check whether the last character is an underscore. So if this is true, I'll add 1 to my answer. If this is true, I'll add 1 to my answer. So like if you are wondering what is happening here, so if this statement is true, it will return 1 and 1 will be added to my answer. If this statement is false, it will return 0 and 0 will be added to my answer. So this is how this particular part works. Now what I do is I run a loop from 1 to less than size of S, and I check whether the current character is an underscore and the previous character is also an underscore. I increment my answer, right? And at the end I can just print my answer. So this would be the solution for the first problem. Now let us move to the second problem of today's contest. That is JoJo's Incredible Adventures, right? So this particular problem says that we have been given a string of size n, and we have to build a square table of size n cross n consisting of zeros and ones, right? So what we do is at the 0th row or the first row, let us assume it to be 0 based indexing because they have numbered it from 0 to n minus 1. So at the 0th row, what we have to do is we have to write the string that has been given to us as it is, right? So we'll just write the string. At row 1, what we'll do is we'll shift the string rightwards by one place and then write it at the first row. For row is equals to 2, we'll shift the original string right by 2 places and then write it at row is equals to 2, right? So once we have done this for all 0 to n minus 1, what we have to do is we have to tell the size of the maximum area of rectangle consisting of only ones, right? So for example, here you see that the maximum size is 6 possible, that is 3 ones here and 3 ones here. So the total rectangle size is 6, right? So we have to tell the maximum size possible. So again, this particular question has had a few cases. You can do it with a bit of casework, but you'll have to be careful about what cases you choose. So before talking about the cases, let us discuss a more general scenario, what can happen, right? So let us assume that there is some 0 here in the beginning and there is some 0 here at the end, and let us say that there are some ones in between, right? So let us assume that there are 5 ones. Now this is the original string and the grid will form like this. So this is the grid, this is the first row of the grid, and if you shift one places to the right, then the grid will be this will be 0, this will be 0, this will be 1 1 1 1 1, right? And if you shift it one more place to the right, what will happen is again 1 here, then double zeros, and then 4 ones like this. Again one place to the right, 1 1 0 0 1 1 1, one place to the right again. So we'll have 1 1 1 0 0 1 1. I think so. This is 3. Oh yeah. So again we can move to the right. So it will be 1 1 1 1 0, 0, 1. Again, we can move one place to the right. So it will be 1, 1, 1, 1, 1, 0, 0. So this is 0, 1, 2, 3, 4, 5, 6. So the total height is 7, and we had 7 number of characters in our original string. So this is the correct grid, right? So let me just show you, like if you made this grid, you must have observed the pattern, but let me just highlight it for you. So you will observe that the first rectangle that you can form is the first rectangle of consecutive ones. So this is the first rectangle that you can form. Now, if you increase like the second rectangle, let me just first form it for you. So this would be the second rectangle that you can form. Now you must have observed that if you increase the height of the rectangle by 1, you will have to decrease the width of the rectangle by 1. Right? Again, I increase the height of the rectangle by 1 more. So the next rectangle would be this one. I've increased the height of the rectangle by 1 and decreased the width of the rectangle by 1. So this is the new rectangle. Right? Again, I increase the height of the rectangle by 1 and it will decrease the width of the rectangle by 1. This is the new case. Again, I can like make one more step. So in the next case, it will be something like this. Right? So I believe that these will be the all overlapping rectangles or the overlapping ones. And if you like try to do it once more, you will run out of overlapping ones. And the rest of the cases will always be smaller than the current case. So we have considered all the cases here, and these particular ones that you see here will just form an inverted copy of the figure that I have just made here, right? So I believe like you must have observed what are the sizes of the rectangle. So if initially the size of the rectangle was 1 into 5, right, because there was one row and 5 consecutive ones, right? In the next step, the size will be 2 into 4, that is this particular rectangle. In the first row, this is in the 0th row, and this I am writing for the second row now. So for the second row, the size of the rectangle will be 3 into 3. For the third row, the size of the rectangle will be 4 into 2. And for the last and the fourth row, the size of the rectangle will be 5 into 1. Right. So you just have to find the number of consecutive ones. So the number of consecutive ones will be this particular value, and you initialize one value with 1. Right. So you do 1 into 5. Then we increment this value by 1 and decrement the second value by 1. So then it is 2 into 4, then it is 3 into 3, then it is 4 into 4, and then it is 5 into 1 again. So like after going halfway through, you will realize that the values will get inverted. So 2 into 4 was here, that is why 4 into 2 was here. But since like the constraints allow us to do it, we can always traverse through all the numbers. It is not a problem for us. We can always traverse through all the numbers. Now we have to take the maximum value among this, right? So this is the very first thing that you would observe about this particular question. Like this is the easy part to observe. Now let us discuss some other cases which is not so easy to observe, right? So what happens when the string is like this, right? So if I want to find the length of the longest consecutive ones, one answer that you might think of is 3, right? Because there are 3 ones together. But this will be a wrong answer. Why? Because if you consider this particular string, they both are exactly the same strings. It's just that the second string is a rotated version or a shifted version of the first string. Because if you shift this particular string by 2 places to the right, then the 0 will come at the end and these 2 will go at the beginning. So the length of the longest consecutive ones is 5 in this case, right? So this is one edge case that you have to consider, right? The second thing that you have to consider is, so this is the second edge case, when the whole string is consisting of ones, right? So the string is 1 1 1. Now if you try to implement the above formula where you do 1 into 3, then you do 2 into 1, and then you do 3 into 1, and you try to take the maximum of it, then this will not work in this case, because no matter how many times you rotate this particular string, the string will still be 1 1 1, and the size of the maximum square would be n square. Right, so this is the value of n is the size of the string, and you just have to square it. This is the case when all of the characters are 1, right? So you will have to consider these two edge cases separately, Otherwise, this particular approach, that is this particular part, will work for all the cases, all of the rest of the cases, right? So let me just quickly summarize what I just explained in this particular problem. So what we are doing is, first of all, we are finding the length of the longest consecutive ones that are present in the string. So once we have found it, what we do is we observe when we try to rotate it one by one. So for the first 0th row, it is the original string. For the first row, when we rotate it by one, we see that there will be some overlapping ones. So now the height, if we consider from the starting, the height of the rectangle has been increased by 1, but since we have rotated the current string by 1, the width of the rectangle decreases by 1, right? Similarly, when we go to row 2, again the height increases by 1, but the width decreases by 1. So we observe this particular pattern, and we found that initially the length or the height of the rectangle was 1 and the width was 5. For the next row, it will be 2 cross 4, then it will be 3 cross 3, then it will be 4 cross 2, and finally 5 cross 1. So we can just iterate through all of these values and take the maximum of it, right? So this is the general case. Now if you consider, there are two edge cases in this particular problem, and that is what happens when you see the string 1 1 1 0 1 1, right? So you must believe that 3 is the length of the longest consecutive ones in this particular string, but that would be wrong, because if you rotate this particular string right by 2 times, then the final string would become this. And now you can see that the length of the longest consecutive ones is 5. So you have to match these characters together, right? So these should be matched. Now the next case is what happens when this particular thing happens, that all of the characters of the string are 1. Now in this case, the above formula will not apply, and you just have to print the answer as n square, where n is the length of the string, because no matter how many times you shift the string will remain the same, and it will form a block or a n into n grid of all ones, right? So this would be the answer for the second problem. Now we can have a look at the code. So this is the second problem. What I've done is, I've taken a string s and I've initialized my variable n with size of s, right? Now I just take two variables. So longest will store the length of the longest sequence or the longest consecutive ones, and current will store the length of the current size of ones. Now I initialize one more variable with count, and count will store the number of zeros that I have encountered till now. So I just loop through the string, and if s of I is 0, then I just increment the value of count, and I just set the value of longest, that is the longest consecutive ones that I have found till now, as maximum of longest comma current. I initialize my current with 0 and I just continue, right? Otherwise, if this does not happen, I increment my current variable, which will indicate that I have found one more amount of 1. So what happens when I have encountered, when the count of 0 is 0? So count will store the number of zeros that I have encountered in the string. If this particular count is 0, that means there are no zeros in the string, and the answer would be straight away n into n, and I can just print my answer, right? So otherwise, what I can do is, so this is the second part. So what I do now is, I initialize one more variable extra. So this is to take care of the string such that, so this is the first edge case that I am taking care, when like the string is something like this. So this is 1 1 1 0 and 1 1, right? So this would be a string like this. Now what I do is, I just start from the starting, and if s of I is equals to 1, I just increment my extra, otherwise I break out of the for loop, right? So initially what I did was, I have initialized a taken vector, which is a boolean vector, which will mark that my current character is taken. So I was having this problem when the string was like this. So the string would have been 1 1 1 1 1. So if the string is like this, then it might happen that all the characters are taken in the first for loop, and all the characters are also taken in the reverse for loop. So I also have a reverse for loop to count the number of ones. But since that particular condition, when there are all ones, have been covered here, I don't need this vector of taken anymore. So I can just safely avoid this particular part, and I can just erase it. So I'm just going to simplify this part for you. So it should be like this, right? Because I'm sure that I'll encounter at least 1 0 in between. Otherwise, if there were no 0, then this condition would have been executed, and I have to just return from this part here. So I know that there is at least 1 0. That is why I do a first for loop, and I just do, whenever I encounter a 1, I just increment my extra, otherwise I break out of the for loop. And the second for loop is the reverse for loop, where whenever I encounter a 1, I increment the value of extra, and otherwise I just break out of the for loop, right? Now I set the value of longest as maximum of longest and current and extra. So you must be wondering what is this current now here. So we have talked about the longest, which is the longest value, extra that I calculated just now, and the current is from here. So after the for loop is like this particular for loop is finished, the last value of current has not been updated yet, so I update it here, right? Now I initialize my answer with 0, and it is the same thing that I have just told you. I do this for loop from 1 to less than longest plus 1, and I just do I into longest of longest minus I plus 1. So this is the same thing that I have told you in the explanation, that I will start getting increased and the other part will start getting decreased, right, by the same factor. So if it is increased by 1, this will decrease by 1. So after it, what I do, I just print my answer, and that will be a final answer. So this was the solution for the second problem. Now let us move on to the third problem. So the third problem is constructive problem. So what they mean by constructive problem? This problem does not require the use of any advanced data structure, and this can be solved with simple logical skills. So despite of that, I still make a few wrong submissions on this particular problem. So let us discuss what the question says. It says that we have been given some non-negative integers and we are allowed to perform this particular operation exactly once. So what is the operation? We can choose some range starting from L to R, and we can replace all of them with a non-negative integer k, right? So this value k will be assigned to all the elements in the range L to R. Now what we have to do is the MEX of A is the initial MEX of the original array, right? So this is the original array. Now if we denote it by M, now we can perform the above operation exactly once, right? We need to perform this operation such that the MEX of the new array becomes M plus 1. So it should be exactly M plus 1. So if earlier if it was M, now we want to make it M plus 1. This is our problem. Now we can discuss a few sample test cases for this particular problem. So what I'll do is I'll just copy them from here. So these are the sample test cases. So we just have to tell whether it is possible or not. So let me discuss how it is possible in the first sample test case. So if it is 1 to 1, so the current MEX is 0 for this particular array. Now I want to make the current MEX equals to 1. What I can do is, a possible way to do is replace all of them by 0. Right. So this is a possible answer. Now for the second array, the second array is 0, 2 to 0. The current MEX is 1. Right. The current MEX is 1 and I want to make the MEX 2. So what I can do is, I can replace these two elements with 1 like this. Right. So this is our problem, and for the rest of the two cases it is not possible. So there is one thing that you would observe about this particular question. So if the current MEX, for example, if the current MEX of the array is M and we want to make it M plus 1, right? So that means M is the smallest element that is not present in my array right now, and M plus 1 should be the smallest element that will not be present in my array after I make the operation, right? So definitely I would want to remove all the occurrences of M plus 1 from my array, right? Because if the current MEX is M, right, so M is the smallest element. If somehow I include M in my array, then M plus 1 is also present there. So the MEX will become M plus 2, right, or some greater value. So if I want to make sure that the MEX will stay at M plus 1, then the best option is to replace all the occurrences of M plus 1 with M, right? So this is one possible answer, right? So what I'll do is I'll explain this part once more. I know that this might sound a bit tricky, but it is very simple. So I'm saying that my current MEX is equals to M, right? I want to make the MEX equals to M plus 1, right? So that means in the current state that M is the smallest element, that is not present in my array. But I want to make a change such that M plus 1 is the smallest element that is not present in my array. So definitely if M plus 1 is currently present in my array, I would want to remove all the occurrences of M plus 1 and replace them with M, right? So this is a possible answer, right? Now the second thing is, what if the current MEX is 0? If the current MEX is 0 and I want to make the MEX equals to 1, what I can do is I can replace all these elements. If this was x, I can replace all these elements with 0. Right. So if the current MEX is 0, I can always replace all the elements with 0 and it is also a valid answer. Right. Now the only case that I have to worry about is this one. Again, here we have here we can have separate some separate cases so that it is easier to discuss. So there will be three types of cases. One is that m plus 1 is not at all present in my array. Right. So if m plus 1 is not present in my array, then I'll have to look for some value so that I can replace it with m. Right. I need to look for some value so that I can replace it with m. How do I know whether some value is present that I can replace with m? So if you consider a case like 0, 1, 2, 3, the current MEX is 4, I want to make the MEX 5. So there is some value, there should be some value in this array that I can replace with 4. Right. But if you see, if I replace any of these value with 4, then the MEX will itself drop to 3 or a smaller value than 3. Right. So if I make it 0, 1, 2, 3, 0, 1, 2, 4, the MEX will be 3. If I make it 0, 1, 4, 3, the MEX will be 2. Right. So it will be always a value less than or equals to 3. So it is not possible in this case. So if I would again repeat, if m plus 1 is not present, this value is not present, I need to make sure that among all the values there is at least one duplicate value. So for example, the array can be one like this 1, 2, 3, 3 or 0, 1, 1, 2, 3, right? So that I can replace this duplicate value with some my current MEX 4 and the MEX will become m plus 1. If there is no duplicate values present, the answer will be no, otherwise the answer will be 1. Yes, right. So m plus 1 is not present. So again, duplicates present, duplicates, no duplicates. In this case, the answer will be yes, and in the other case, the answer will be no. Right. So this is the first part where we discussed when m plus 1 is not present. The second part is when m plus 1 is present and all the m plus 1s are together. And what do we mean by m plus 1s are together? So like for example, in this particular case, let us assume that the value of m plus 1 is 2. Right. Like this. So you see that all the 2's are present together. Right. Or I can write it, if I write it like this, then you will see that some 2's are here, some 2's are here. What is the benefit when all the 2's are present together? What we can do is I can replace all of them with one single value, right? So if all the 2's are present together, if all 2's or if all m plus 1's together, if they are together, then the answer is always possible. Why? Because I can replace all of them with my desired value, right? But what happens when m plus 1 is present and they are not together? Right. So for example, if 3 of them were here and 1 of them was here. So in this case, again, I'll have to check something. Now you see that we can only make exactly one operation and we need to make sure that we can remove all of these 2's. Right. So obviously my range should be from this particular position to this particular position. So what I need to do is I need to remove all of these 2's together and I need to replace them with my desired value. But if by removing this whole range, my current MEX changes, then it means I cannot form my answer. I should only be able to remove all of these 2's such that my current MEX does not change, such that all the values present to the left of it and all the values present to the right of it still make the same MEX value that was being made by the original array. If this is true, then the answer is possible, otherwise the answer is not possible, because the new MEX will always be some value smaller than the current MEX, right? So I hope you get this point. Let me repeat it again for you. So if some 2's are here, so if this is 0, this is 0, this is 2, right? In this particular case, I can only make one operation and choose the range L to R like this, right? I can replace all of these values with my desired value. So if all the elements to the left of it and all the elements to the right of it still can make the same MEX, then the answer is possible, otherwise the answer is not possible. So like you would have observed that this second case is only a special case of the first case, where this particular 2 was present here. So it was like 2 2 2 0. We were still considering all the elements other than these elements, right? So all the elements to the left of it, all the elements to the right of it. So if you don't write this condition separately, then it is okay, but if you write it separately, then it is also fine. Both of the ways are correct, right? So let us have a look at the code now for this particular statement. So during the context, I implemented these three cases as separately, but you can also merge the second case into the first case, where you can just count or you can just find the first and the last position of the element you want to remove and calculate the MEX of the remaining elements, right? So that approach will also be correct. So let us have a look at the code now. So what I have done is I have created a vector of size n and I have taken input in it. So after I do it, I create a copy of the original vector and I just sort the copy. Now I try to find the MEX. So the current MEX is 0, and what I do is, if copy of I is not equals to current MEX, that means the element is not equals to the value that I am finding, and the current element is also not equals to the element present before it or the previous MEX. So what is actually happening is, let me just show you. So if the first element is 0, my MEX will be 0 here, right? Now the second element can be 1 1 1 because they can be repetitive elements, and then it can be 2 2 like this, and let us say it is 4 here, right? So initially my MEX is 0. When I see that these two values are equal, I upgrade my MEX to 1. I see that these two values are equal, I upgrade my MEX to 2, right? So this particular value should either be 2 or it can be 1, right? It should not be any other value. So it can be 2 when I found the next value. It can be 1 when there are duplicates of the same value, right? So there should be not any other value. So again, I remove my 2 here, and this is a value less than 2, that is 2 minus 1, and that is equal to 1. So I believe that this can be correct. And then again, I match these two values. These are equal, so I may upgrade my MEX to 3. This is 3 minus 1, that is 2. Again, I upgrade my MEX to 3. That this 3 will remain same, and then these two values are not equal. So the second value is not equals to 3 and it is not equals to 2. That means I found my MEX equals to 3, right? So this is exactly what we are doing there. And if both of the conditions are false, I just break out of the for loop. Otherwise, if the current value and the current MEX are equal, I upgrade my MEX to plus plus, right? Now I create a variable called want. So this is the value that I want to remove from my array. So again, I just traverse through the element, and so in this particular for loop, what I am doing is I am trying to find the number of segments of the value that I want to remove. So in this particular for loop, the variable count will store the number of consecutive subsegments such that it is consisting of only this particular variable, that is current MEX plus 1 or want. So this is the element that I want to remove. So I'll leave it as a task for you to go through this particular for loop and understand what is going on here. I have explained what is the functionality of this for loop, but I'm not going to explain the each and every for if else statements. Also, there is one more thing I am doing in this for loop, and that is inserting every element into a set. So I'll tell you later how this particular set will help us. So as I've explained, if the MEX that I want to make is 1, I can replace all the elements with 0, and that way the MEX will be 1. So in this case, the answer will always be yes. So if the number of subsegments such that it contains my element that I want to remove is greater than 1, that means I have to go to the first and the last positions. So in this particular for loop, I am updating the first and the last positions of the element. So if V of I is equals to 1, I'll update my last as I. And if V of n minus I minus 1 is equal to 1, I'll update my first position as this particular value. Now, after this for loop has been executed, I initialize a set called current. So these are all the values that are present to the left of the first occurrence of the element that I want to remove. Then I insert all the values that are present to the right of the last occurrence that I want to remove. Then again, I initialize my MEX is equal to 0. I calculate the value of the MEX. If the MEX is equal to the current MEX, that means the answer is yes, otherwise the answer will be no, right? Now again, I can come to the else if part. If the value of count is 1, that means that there is only one subsegment such that it contains the value that I want to remove, then the answer will be yes. Otherwise, if I go to this else part, that means there are no sub-segments that contain the value that I want to remove. So I'm recording this part of the video later on after I recorded the whole video. I realized that my third problem failed on some main tests. So it failed on main test 10. So the problem I'm telling you, the only difference in the code was the way I was checking it here. What I was doing is I was like trying to check the size of the unique elements. If it is less than n, I was printing yes, otherwise I was printing no. So the problem with that approaches, I will explain you with the help of some example. So for example, I considered the case where the elements were like this 0, 1, 2, 3 and the MEX was 4, right? But there can also be a case when there are all the 4 are unique elements like this, but the MEX is still 3, right? And I can form the MEX 4 by replacing this particular element with 3. So in that case, the MEX will become 4. That will be my desired value. So you could have like done this way. The way I implemented that part was wrong. So that is why my answer failed on main test 10. So I was just telling so that you don't make this mistake. And here we will have to check whether the current MEX is equals to n or not, right? So if this is equals to n, then the answer would be no. Otherwise, the answer can always be yes, right? So I'll be inserting this part of the explanation in between the video. So it will have a few cuts here and there. But the main objective is to make you do the correct solution. So that is why I inserted it in between. So I tried this with this particular change, and the rest of the solution is absolutely correct. You can go up, you can go with it. The only change that we'll have to make is the way we are checking the last part, right? So that's it. So this was the solution to the final problem, that is the C problem. So like in this particular problem, the code is a bit messy, but you can always write it in your own way. I have explained you the solution to this problem and how you can solve it. So this was the solution for the first 3 problems of today's Codeforces round. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to subscribe to the channel. It's always free of cost, and you can always unsubscribe later if you don't find the content interesting. So till the next video drops, keep coding, stay safe, bye bye.